Ooh, we are on to our second section here. The whole chapter is called Sequence and Series. So far, you've learned what a sequence is. It's a pattern of numbers. Or a number pattern? Same difference. A series is a sequence where you add everything together. So the good news is, if you could do the last thing, this is easy. Today, all we're adding to the process is adding them up. Now, we are going to talk about sigma notation, which looks funky. If someone ever wants to scare you on the cover of an algebra book, they'll put this stuff right here and make it seem like it's this crazy thing. It's not. It's easy. If you can add and plug in some numbers, then you know how to do this. It just looks weird at first glance, so we're going to figure that out a little bit. All right, so that's our goal, and we will play around with that a little bit and maybe even adjust some of those questions as I look at them. All right, here we go. Series. So up here on the top, I just gave a couple different things here. This was bell work. So if you're in my classroom on a day-to-day basis, we would do bell work where we would practice basically the thing we did the day before. Let's pick one of them and do it. So 2n squared. I'm finding the first three terms of the sequence. So I would find a sub 1. So 2 times 1 squared. So 2 squared would get me 4. Then we would find a sub 2. 2 times 2 squared. 2 times 2 is 4. 4 squared, 16. And we go a sub 3. 2 times 3 is 6. 6 squared, 36. Am I adding the same thing each time? Nope. Am I multiplying by the same thing each time? Well, I multiply by 4, and then I didn't multiply by 4 again, so that's not going to work. I looked at my multiple choice answers down here. It does look like I got to do one more. I get 64. Nope, just kidding. I circled the wrong one. Don't look at that. It's 416. That's why I didn't need to do the third one. All right, there we go. We just plugged in numbers. Is it arithmetic? No, it's not geometric. It is neither. If we did the same thing here, a sub 1 is going to be equal to negative 10 plus 3 times 1. So that's negative 10 plus 3 would be negative 7. A sub 2 would be negative 10 plus 3 times 2. So negative 10 plus 6 is negative 4. A sub 3 equals negative 10 plus 3 times 3. Negative 10 plus 6 would be, or plus 9, sorry, is negative 1. So we've got negative 7, negative 4, negative 1, negative 2, or negative 1, 2. I am adding 3 each time, so this one is an arithmetic sequence or an arithmetic sequence. But today, what we're going to do is a series. A series is a sequence. Siri thought I was talking to her. A series is a sequence added up. That's it. It's the same thing. So if I had this pattern, negative 7, negative 4, negative 1, 2, the series is just what do you get when you add all those numbers together? And that's what we're doing here today. So don't let it be any harder than that. Find the sum of the following series. And so if you notice here, really the only difference between what we did on our last section and this one is that there's some plus signs in between. So I'm finding the sum of the series. I'm just adding this all together. All right, so 2 plus 4 is 6. Plus 6 would be 12. Plus 8 would be 20. Plus 10 is 30. That is the sum of this series. I brought down the next one each time. It just made sense to me. So the sum of the series is 30. It was a pattern. We added 2 each time. It was an arithmetic sequence, but that became an arithmetic series with the sum of the first 5 terms. Same thing on the next one. 5, 15, 45, 135. I'm just adding together. 5 plus 15 is 20. Plus 45 is 65. Plus 135 would be 200. Done. That is the sum of the series. Find the missing term in the series and then find the sum. So this is just a pattern thing. 96 plus 48 plus 24. What am I doing each time? Am I adding the same number in the sequence? No, it looks like I'm 96 becomes 48, becomes 24. I'm cutting it in half. It's a geometric series where my ratio is a half. It goes from 6 to 3. So what number would go in the middle? It'd be 12. They're asking you to find the sum of the series. That's easy. That's just adding the numbers together. 96 plus 48 plus 24 plus 12 plus 6 plus 3, 189. I use my calculator. Find the missing number, 51, 61, 71, 81. Is that arithmetic, geometric, or neither? That is an arithmetic sequence because I'm adding 10 every single time. What is the series? It's 264. That's what I get when I add those four numbers together. Next one, 22, 15, 1, negative 6. Let's look. I subtracted 7, and here I subtracted 7. And to go to 15 to 1, I subtracted 14, so it makes sense that I subtracted 7 once and then subtracted 7 again. So 15 minus 7 would get me 8. That seems to make sense there in the middle. To find the sum of the series, I'm going to add those together, and I get 40. Example 8, 3, negative 6, 12. Well, to go from 3 to 6, I subtracted 9, and that's definitely not what I did there. So I didn't subtract. What about 3 times what would get me negative 6? Well, times negative 2 would get me negative 6. If I multiplied that by negative 2, it would get me positive 12. I multiplied that by negative 2, it would get me negative 24, and then 48. So that's a geometric sequence with the ratio of negative 2. I'm just going to add it together in my calculator. Boom, I get 33. That's easy, finding the next term and then adding them together. There's a different way of writing this, though, called sigma notation, or sometimes you will see summation notation. When you see summation, that sum in math class means add. So this is when we're going to plug in some numbers, create a list, and then add this up. All right, so this right here is the Greek letter sigma. Okay, that is sigma. If you ever join a fraternity or sorority later in life, you will see that quite often. You go to college, you'll see that. That's sigma. All right, so sigma in math class represents finding the sum. Sum, sigma. They both start with S. All right, here's how this game works. When you see this concept right here, this setup, the bottom number is going to be what number you're going to plug in to get the first term. And so to get the first term in this setup, I'm going to take the number 1 and I'm going to plug it in for the letter. So I'm going to plug 1 in for k. So 7 times 1 would get me 7. And then I'm going to increase my k value by 1. So now it's going to be 2 that I'm plugging in. So 7 times 2 would get me 14. And then I'm going to increase it by 1. 7 times 3 would be 21. 7 times 4 would be 28. And then I'm going to do 7 times 5 is 35. And then I stop. I stop because this top number is what number do you stop everything at? You stop at the number 5. So I start at 1, I plug in 1, I plug in 2, I plug in 3, I plug in 4, I plug in 5, and then I stop because that's what I have on top. This is not the answer to the question. The whole sigma thing means find the sum. So the answer to this question is whatever 7 plus 14 plus 21 plus 28 plus 35 is. So I'm plugging that into my calculator real quick because I don't want to do that math. The answer to this thing, this is equal to 105. And that is the only answer to this question. This is a series setup having you find the sum of all the different numbers in that pattern. Let's go to the next one. So this time, N, they didn't use K, they used letter N. Who cares? They normally go back between K and N. Sometimes they use the letter I as well, just because they can be mean. All right, so it's a sigma notation. I need to find my list of numbers. So I'm going to plug in 0. If I plug in 0, I get 0 plus 1, which is 1. Then I'm going to increase my N value by 1. So 1 plus 1 is 2. And then 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. 5 plus 1 is 6. 6 plus 1 is 7. And I stop because I just plugged in 6 for N. That's all I'm doing here. I'm adding all those numbers up. So in my calculator, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. My answer is 28. That is the sum of this series. That is the answer to this question. The whole thing, the answer is 28. These numbers are great, but that's not the answer. The answer is 28. Let's try another one. So I'm going to make this one a little bit easier. Instead of the number 1, let's make k equal to 4. It doesn't have to start at 1 or 0. It can be whatever number we want. If I made it k equals 4, that just means the first number I'm going to plug into this pattern is the number 4. So 4 squared. And then I would add to that 5 squared. And then I would add to that 6 squared. And then I would add to that 7 squared. That's what I'm doing. I'm plugging in 4, then I plug in 5, plug in 6, and I stop when I plug in the number 7. So 16 plus 25 plus 36 plus 49. That is the answer to this question. 16 plus 25 plus 36 plus 49 gets me 126. That's it. That's not an arithmetic or a geometric sequence. I added 9, and then I added 11, and then I added 13. Not a pattern. It's not adding the same number each time, so it's not arithmetic. Next one. We're plugging in 1. Then we're plugging in 2. That's 9. Then we're plugging in 3. Then we're plugging in 4. And I'm going to stop because 4 is my top number. I'm taking 3 plus 9 plus 27 plus 81, and I get 120 as the sum of this series. Let's try 2 more. Let's look at this one. Let's make, just to make our life a little bit easier, let's make n equal to 2. Why? Because I changed it. Make n equal to 2. So we're going to plug in 2. So 2 minus 2 would get me 0, times 2 would still get me 0. Then I'm going to plug in 3. This is 1 times 3 is 3. Then I'd plug in 4. This would be 2 times 4 would be 8. Plug in 5. 5 minus 2 is 3. 3 times 5 is 15. And then I would stop because that number right there tells me the stopping number. So I'm going all the way to 5 and then I stop. That's not the answer. The answer to this is what I get when I take all of these numbers together. 0 plus 3 plus 8 plus 15. I get 26 as my sum. Last one, plug in 1. Plug in 2. Plug in 3. Plug in 4. Figure out what my numbers are. So -6, -12, -18, -24. Not the answer. The answer is what I get when I add all those things together. I get -60. The end. So that series, again, series is just taking a pattern. Like this is an arithmetic sequence. All right, I went 6, -12, -18. I'm subtracting 6 each time. But the series aspect is you adding the numbers up. When you see that, that's called sigma notation or summation notation. It means that you're plugging in all the numbers and then adding for a final answer. Hope that makes sense.